Good. So people are still slowly coming in, but we'll get started now. So I'd very much like to welcome everyone to this event it's the 8th webinar in this discussion series on tipping elements, irreversibility, and abrupt changes in the Earth system. My name is Jonathan Donges from the Potsdam Institute for Climate Impact Research. And so I'll be moderating this event today. The goal of this discussion series is to advance knowledge on tipping elements, support developments to increase the consistency in treating and researching these tipping elements in the scientific community. It's about developing a research agenda, joint research experiments, and also towards shaping the idea of a tipping elements model intercomparison project, the TIPNet. And this series is organized by several large research networks, the Earth Commission, which is a team of global scientists with the mission to define a safe and just corridor for people and planet. It aims the analysis, integration, and modeling of the Earth System project of Future Earth, which is a network of Earth system scientists, but also social scientists that seek to develop ways to understand complex phenomena in the Earth system and their interaction with human activities, including with the focus on tipping elements increasingly. And both aims and the Earth Commission are hosted by Future Earth, which is by itself a global network of, again, researchers, scientists, and innovators towards sustainability. And finally, the third large network that supports this series is the Safe Landing Climates Lighthouse activity of WCRP, the World Climate Research Program, that explores also routes to safe landing spaces for human and natural systems. So that's our common themes. And the focus today is on social systems and tipping towards positive change. So really going from this doom and gloom and the risks of climate tipping elements, which are of course very important to understand, more towards seeing tipping elements as an opportunity in accelerating rapid transformations in society towards sustainability. And now to give you some house rules on how this will work, both of our speakers will present before the Q&A session, so you can post questions in the chat and in the Q&A tool, and please indicate to whom your question is directed in the Q&A feature in Zoom. And then people are invited to vote on questions that they find particularly relevant, and then questions will be answered in a discussion session that follows both presentations. We will set up also an interactive Miro board where you can leave comments and suggestions for future research and collaborations and so on, which can then be accessed through the link in the chat box. So it has just been posted. And this Miro board it's not just for today, but it will be kept open for the whole week to foster further discussion and collaboration. And then finally, following the event today, there will be a recording of this seminar on the Tipping Point series webpage, and it will be on YouTube, as I understand, so it will be accessible in the future as well. So you can also share it with colleagues that couldn't be here today. Now, that was on the technicalities. I'm now very excited to introduce Ilona Otto, the first speaker. She's a professor of societal impacts of climate change at Graz University at the Wegner Center there. And we've collaborated for quite a long time at PIC. So I know that she does great work on social tipping elements, and she leads a group now there at the Wegner Center on social complexity and system transformation, using complex systems theory and novel methods to study societal dynamic processes and interventions that can trigger rapid transformations. And so her focus is on sparking these rapid social changes that are needed. And she uses various research methods, including more classic social surveys, case studies, but also behavioral experiments and agent-based modeling experiments, for example. And yes, Ilona, thank you very much for being here, and the floor is yours. So you have 20 minutes for your presentation.
Yes, thank you, Jonathan, for this nice introduction. Yeah, it's great to be here with you, with Doyne, and I had a look at the list of our participants, so I saw many familiar names. So Yeah, great to welcome you, and I'm also looking forward to your feedback, because it's, as Jonathan said, it's work in progress, and I think it's just kind of rising research agenda. So yeah, so this is really nice to start this. Okay, so I hope you can see now my slides. Exactly. So I will talk more about the perspective of social sciences on social tipping dynamics and what can we learn, and maybe also what are the important research questions. I will start with the challenge that is ahead of us. So this figure shows historic changes in the CO2 emissions and then the future. Yeah, so first of all, if you look at the historic changes, the only periods where the emissions stagnated or decreased were related to something what we may call a social collapse, so like the periods of wars or like the financial crisis, and also recently the COVID-19 pandemic. But interestingly, as soon as those crises were over, the emissions started to increase again. And this is also something what is happening right now. So after this drop due to the pandemic, the emissions are again on the rise. And actually we are closer or almost there where the business as usual scenario leads us. This red curve, yes. So this means that if we continue emissions on this pathway, we will get to a world that will be about 4 degrees on average warmer at the end of the century. And of course, we don't want to get there, yeah? And the question, what can we do and what are the alternatives? So this blue curve shows the scenario that is compatible with the Paris Climate Agreement and means limiting the global warming to 1.5 degrees at the end of the century. But if you look at this blue curve, it's very challenging. Of course, there are many different scenarios, so it's just like one example scenario. But it just shows that the challenge is ahead of us. And those different colors, they correspond to not like kind of traditional economic sectors, but to something what we might say, like if we look now where our agency is to limit the emissions. And about 70% of the emissions can be related to something what we call like behavior and lifestyle changes. So the area that is actually that we can influence as citizens. But of course, to get there, we also need those infrastructure and supply changes that are shown here with this darker yellow color. And finally, land use, agriculture is very important because from an emitter of CO2, land and agriculture have to become carbon sinks. Yeah, it's also very challenging. And at the same time, if you think about renewable energy production, most of energy will have to be produced in the future on the Earth's surface. So it means there also huge competition and probably conflicts over land use in the future. And this scenario is also all other 1.5 degree scenarios, they won't be possible with also technological CO2 removal. So this is also really challenging because currently we don't really have good technologies for this. And it's important that those technologies will be developed in the next years. Yes, so this is the challenge, and the question that I'm asking is how can we get there on this 1.5 degree pathway without compromising human well-being? So the question is, how can we get there and maintain social stability, integrity of our ecosystems and also human well-being? Maybe also something what is interesting here, that if you look at this curve and the rate of change that is behind, we are talking about a rate of change of 7% and more per year. This is an area that is related to like non-linear change, yeah, or kind of exponential change. And interestingly, in most of social sciences, we, especially in the social sciences in the 20th century, we used to deal with more kind of linear change, yes? So sort of the assumption that that there are no kind of dramatic changes in the system, and kind of we just stay on the kind of the pathway that was in the past, and things kind of change slowly about a rate of like 2% per year or less, and kind of we had very few theories and models that allow us to kind of imagine kind of like more like rapid change or also like emergence of new types of equilibrium. But there is some evidence that that of course no rapid change is possible. So there are, for instance, models from financial markets, from public opinion change, but also experiments, models, and data on social norm change that show that actually like a tipping or kind of rapid change, kind of going from one state of the system to another is actually is happening in the real life. So just think about the financial crisis, of course, in 2008, and such rapid changes do happen. But the question is also how to conceptualize them. In the papers, actually, Jonathan, me, and also a few other colleagues, we put forward this definition of social tipping elements, which are parts of the system where rapid change can be observed. And also these are parts of the system where that we can influence with our human agency. So we put forward this definition of social tipping interventions. So these are interventions that are likely to lead to those rapid change dynamics within social tipping elements, so parts of the system where rapid kind of contagious like changes is possible. And in our research, we asked international experts, and we also ran a workshop of literature review. And those are the questions. So what kind of social tipping elements and social tipping interventions are relevant for inducing a rapid and global decarbonization by 2050? And interestingly, most of the experts that we asked, they actually believe that this is possible, that this can happen. And there were only just a few experts, maybe not more than 4, that said like this is not possible. Like you need like a war or like a global pandemic. It was actually before Corona and before, of course, the war in Ukraine. There were just very few experts who said that this is not possible. We need some sort of like destructive interventions or events to get there. But all other experts, so over 100, they believe that this is possible, and we do have the agency to induce such changes. So this was actually quite an optimistic message overall. And now I will show you briefly the results, kind of detailed results of this expert elicitation that we ran. So the experts we approached, they nominated 6 so-called social tipping elements. So those areas within the social and economic systems where you can observe rapid social or rapid change. And then also the experts referred to so-called social tipping interventions. So type of interventions that you need to do to release this kind of this tipping or rapid change within those subsystems. So the experts talked about energy production and storage system, and here introducing subsidy programs for renewables, decentralized energy generation, then human settlements, so basically building carbon neutral cities, financial markets, and here the intervention was the divestment movement, the system of norms and values, and the intervention here is recognizing the immoral character of fossil fuels. So basically, if you feel bad about using fossil, like morally bad, if you feel start feeling like this, if you use fossil fuels, and interestingly, this is happening. So I and also many of my friends, also students, they do feel really morally bad about like if they have to drive or fly. So I think it's a very interesting area. Then the next social tipping element candidate is education system. Yeah, so introducing more programs of climate education and also at all levels of public education. So the intention here is that all students would learn about climate and also know what you can do and the transformation and ideas behind us that here changes happen slowly, but as soon as you have a new generation of young students and leaders entering the job market, then things can change very rapidly. And finally, the last intervention corresponds to information feedbacks. And here's the emission information disclosure. Yes, so the idea is that it should be transparent, for instance, what kind of emissions can be linked to the production of different products, but also services. So currently we don't know. If you go to the shop, like it's like, of course you can have an idea, but it's very difficult to say like what kind of products have lower emissions. Yeah? And what does all interventions have in common? So what they have in common is actually that in all those areas you can observe this this rapid change as possible, and also that small groups, like a small minority, can lead to a change among the majority. So just one example could be the financial markets and the divestment movement. And actually, Jonathan and his colleagues, they ran a model that shows that you need actually just around like 9% of investors who divest their assets, and the rest will follow because they will be afraid of losing their money. Yeah? So those kind of those small minorities can lead to the change among the majority. So basically, this is here you see the same results, but kind of ordered more according to the level of social structure where you need to intervene, and also according to the different time scales. So some of those changes that I was talking about, they can happen very quickly, and they can also manifest very quickly. So for instance, like changes in financial markets, some need more time. And you might ask me, so why should we care about those kind of slower system changes? Why not to focus on only on those rapid changes? And the problem is the rebound effect, or also kind of like bouncing back of the system. Yeah? So if you have changes only at those kind of lower system levels, the level of resource allocation, market exchange, the problem is that you might achieve some change, but then the situation can kind of bounce back very rapidly. So just think about like the corona pandemic. Yeah, that we did reduce our emissions very rapidly, but then there was this massive effort to restabilize the system and bring it back to normal, and now our emissions are on the rise again. So therefore we need those changes at the level of technology, infrastructure, governance, also policies and regulations, and finally at the level of social norms, customs, also religion, that would kind of stabilize this new emerging system. Maybe one more interesting issue is like if you look at the feedback with the climate or the tipping elements in the climate system. So actually there are those feedbacks. Yes, so there is a lot of, maybe not a lot, but there is some research showing that environment, not only environmental, but in general catastrophes can be used as windows of opportunities. Yeah? So during periods of disruption or catastrophes, like usually people are kind of out of the normal, and they are more willing to accept, for instance, rapid policy changes. So what we propose in this work is that this is very important to focus on also on the timing of intervention is very important. Yeah, because sometimes like if you target the intervention in the right time, you can achieve much faster effect. An example could be, for instance, you can imagine now the corona pandemic, and there were those massive amounts of subsidies available for different companies. So you can imagine now if there were some conditions put on those subsidies, that for instance, yes, you will get the subsidy or the compensations, but for instance, you have to propose like plans how to get to climate neutrality in the next 10 years, or at least know how to halve your emissions or something like this. Unfortunately, this does not happen. But again, I think this is an area where we should look more. And for instance, even right now, like the war in Ukraine, it's also a chance, like for instance, for the EU to invest in renewables instead of negotiating contracts with Saudi Arabia, for example. Exactly. So this is our list of candidates for social tipping elements. And I should also say that this research was done 3-4 years ago. So it's maybe not like the completely. So it's not like some list that okay, that's all. But it's more like a list to start with, because like many things changed. Yes. So for instance, something what I observed, like the health systems, they play an important role, and also people are very sensitive to also kind of health co-benefits of climate policies. So maybe this is an area that should be added to this figure as well. Okay. I'm getting towards the end, but I also want to mention carbon inequalities and the role of inequalities, because I think they are really important in tipping the system to climate neutrality. So there are those large inequalities that exist currently in the emissions of different social groups that are related, of course, to their lifestyles. And at the same time, the kind of less powerful social groups and those whose emissions are very low, they are more exposed to climate change impact. And this is an important question, how to allocate the remaining 40% of the carbon budget that we have for staying below 1.5 degrees. And this is a social question, and it's a justice question. Actually, we don't know the answers. So like what kind of principles should we use, and how should we motivate, especially those very high emitters who also have very high agency to lower their emissions. This is an example of research from Germany that show that there are those really large emissions in different social groups. So this is these are emissions in different social groups from the sector of transportation. So the transportation that emissions from like using car or public transportation, or also flying. And these are different emission groups in the German society. And this orange curve is interesting because it shows average emissions in different groups. So you see the people who are quite many, but they have very low emissions on average. And then you see here like just a few survey participants who are very few in the society, but they on average they have about 20 times higher emissions than those in the lowest group. And this is like here those highest emitting groups. These are kind of like upper middle class people. So there are no kind of billionaires and billionaires there, and still the differences are tremendous. But if we start talking about millionaires, billionaires, the differences are even larger. And what is interesting, if you look at the historic data, the emissions actually in the lower earning groups, they actually declined over time. So this is data from the EU, and the emissions of the more wealthy citizens, they increase over time. So this is also kind of a massive justice question. And it's not only about individual differences, but there are also those large differences if you look at the emissions from various companies. So only about 20 global companies, are responsible for about 35% of global CO2 emissions. So at the end, it's not such a large number. Of course, these are mainly companies in the oil and gas sector, but still, it's those differences are enormous. And also, this is an example of my very recent research. We look at the projections of the oil and gas and coal extractions that are prepared by big carbon majors, so those kind of big fossil fuel companies. And if we compare their projections of extraction with IPCC projections and also International Energy Agency projections. And and this is a scenario that is run by BP, and this is a scenario by ExxonMobil. for oil, gas, and coal. And you see the gap, yeah? So it's kind of, you might say there is like a large ignorance of most of fossil fuel companies of Paris Climate Agreement, yeah, and also of the target that we need to get. And by the way, I've heard actually in the most recent BP scenario, they kind of lowered the extraction projections. So this is not up to date, but I think it shows the gap. And why should we care about those inequalities? And why should we care about the role of privileged? And I refer at the end to results of behavior experiments that I ran with my students. And we ran a common pool resource behavior experiment where basically a group of players, 5 players, they had to first invest in water provision and then extract water from a hypothetical irrigation channel. And those decisions were made in the upstream downstream order. So the upstream players, they were the first to take water from this channel, and they could take as much as they wanted. However, if they took everything, then like in the next game periods, the lower or the downstream participants, they did not invest anymore in the common pool resource. Yeah, so at the end, like kind of, there was this risk of getting to the tragedy, and kind of using up all the water or the resources in this game. And then we tested how players respond to uncertainty, so kind of a drying trend in the weather. And also what kind of how do they adapt to the uncertainty? And so I will spare the details of this experiment, but what we found out that is that the upstream players, so those privileged, they have a very important role in kind of tipping the holding dynamics within those experiment groups. Yes, so if the upstream players, those privileged players, if they kind of cooperate and share more equally the resource with downstream players, like you observe kind of emergence of kind of like a cooperative spirit in those groups that are able to adapt to weather uncertainty, and that also are able to adapt to weather uncertainty, and are kind of able to overcome this kind of unfriendly environment created in the experiment. However, if the upstream players kind of greedy and take what they can in those experiments, then it kind of spreads to the rest of the group, and then like you have basically like just kind of uncooperative game where everyone contributes very little or not at all, and you kind of observe this kind of strategy of the commons. So I think that's why this is very important, that those upstream or privileged companies and individual citizens, they have a very important role because they have high agency, and also they have this kind of downstream effect on other groups of citizens. Okay, that's basically all. Maybe a few summary words. So there's no rapid silver bullet for rapid decarbonization. I think it seems like we need like massive interventions at different levels. Also, those social changes are extremely important. So not only technology, I think, is important, but we need like massive changes in the education systems, in social norms, but also in infrastructure and governance. Values and norms are extremely important. And those carbon inequalities are very likely to play increasingly important role in the future, also in the implementation of climate policies. And again, there was this repeated evidence that small minorities can tip the majority of participants. And finding who is in the critical minority, and you can say it's all of us: energy producers, teachers, medical doctors. So, and I think it's also important to not to talk only about individual agency that we have as consumers, but also about strategic and collective agency that we have as citizens, as social groups, as social movements, and also the agency that is needed to change actually the law, the system that we are living in. So I believe we need more regulations, more bans, and not just kind of just waiting for individual customers to respond and to initiate those changes. Okay, that's basically now, and this is the poster that we made for one of Fridays for Future demonstrations. Thanks a lot.
Thank you, Ilona. That was great. So let's give some hands to Ilona virtually. Yeah. So as we had announced earlier, but I'd just like to repeat that quickly for you. We'll have a discussion session after the next talk. So please post questions in the Q&A box and not in the chat. That would make it easier to keep track later and make sure that your questions reach the speakers. Please also start voting for questions that you find particularly interesting, and also use the Miro board. So it is now moving on, my pleasure to introduce Professor Doyne Farmer, who's the director of the Complexity Economics program at the Institute for New Economic Thinking at Oxford Martin School, and Bailey Gifford Professor at the Mathematical Institute at Oxford, and also an external professor at the Santa Fe Institute. So he's of course a very famous complex system scientist, but now his current research is more in economics, including agent-based modeling, financial instability, and technological progress. He was the founder of the Prediction Company, a quantitative automated trading firm that was sold to the United Bank of Switzerland a couple of years ago. But now, and his past research, as I alluded to, included and still includes, of course, complex systems, dynamic systems theory, time series analysis, and theoretical biology. So really broad. Doyne, so I'm really excited to hear your current thinking about social tipping. So please, the floor is yours. And you have 20 minutes.
Thank you, Jonathan. So I'm going to share my screen now, hopefully. Oops, let me see, hopefully. Slideshow. So is everything okay? Can you see my
Just need to swap
slides,
the displays at the top again.
Okay, let's swap the displays. Swap displays, here we go.
That's
Okay,
perfect.
now,
that's perfect.
Good. Okay, so thank you very much. I'm very happy to be here, and thanks to Ilona for a very nice introduction. I think our talks will be very complimentary today. I'm going to focus on the energy transition quite specifically. I'm going to focus on a technological aspect of this, and you know, just to start out by remembering that energy makes up about 75% of emissions. And my message today is going to be that we can deal with that 75% of emissions, eliminate them quite quickly. We can make a green energy transition and make a profit from doing so. In other words, even if we didn't have climate change to do it, we should do this for purely economic reasons. And so roughly speaking, I'm going to say that can happen by just continuing on trends that already exist, and that they're exponential trends, so they have remained invisible in some way up until just recently, but they will explode very soon. But I'm going to focus in the theme of this workshop on the roadblocks to making this happen, and asking what are the sensitive intervention points. And by sensitive intervention point, we mean something I think quite close to what we mean by tipping points as well. But maybe the focus is on thinking about the system and where are the places where we can intervene and where we'll get the most bang for the buck. Where will our efforts make the most difference in giving us a payoff? And in particular, perhaps there are places where very small efforts can be enormously amplified to have really big effects. Now, I want to begin by looking at the evolution of the global energy landscape through time. And so on the left you see the costs of different sources of energy. And on the right, you see the deployment of those sources of energy. So when you look at this, and I know to stare at it for a minute, if you look at over on the left side of the diagram on the left, we see oil, the black dashed line, or coal, the brown dashed line, and gas. And those are striking in that although they jump around, there's volatility, and there may be slight regime shifts. Roughly speaking, costs have remained the same for the last 140 years once you adjust for inflation. In contrast, if you say look at solar energy, which is the orange curve coming down from the top, or wind, which is the blue curve there, or batteries, which is the purple curve, you see costs coming down quite quickly, consistently, and exponentially. Now, to move over to the right side of the curve, where we document the evolution of how we make energy over the last 140 years, you see, starting on the left, coal and biomass are roughly equal at the beginning of that period, and the dominant sources of energy for the world. Coal takes over from biomass and keeps growing. Oil and gas come up from the left, the dashed black and gray lines, and rise exponentially, and then roughly become even with coal. And then you see nuclear power in this pink line coming up quite quickly, but then flattening out. And then you see wind, batteries, solar, and hydrogen-based P2X fuels shooting up at an exponential rate of the order of 40% per year over the last several decades. So you see something quite different happening, because you see these four technologies are rising exponentially in terms of deployment, falling exponentially in terms of cost, and there's a congested zone right now where lots of different energy sources are in competition with each other at around the same price. So we're at a very unique point in the history of energy, and something will happen. And I think you get a real hint from this that all we have to do is preserve the trends of those four key technologies, and we would solve our problems. Now, we're going to take advantage here is the fact that in technological change, technologies behave very differently. The rates are highly persistent, and we can use this to make predictions. So in this slide, we see several different technologies from the United States economy over a span of 20 years. And you can contrast on one side televisions, which are the one on the bottom, which during those 20 years, once you adjust for quality, dropped in price by a factor of 20, to hospital services or college tuition and fees in the United States, which rose by the order of roughly doubled in cost over the same period of time. And so that shows you there's a lot of diversity, but it also shows you the persistence. Televisions dropped in cost every year. College tuition and hospital services went up in cost every year. So there's enormous persistence. There's enormous heterogeneity, as you see in this slide, where we plot growth rates or improvement rates. So off to the left, we have things that are improving really quickly. In the body, we see this bell-shaped curve of technologies that are all behaving roughly similarly. And then there's a very heavy left tail of the technologies that improve. Now, how do we take advantage of this? Well, we can make use of empirical laws for forecasting technology costs based on historical data. The earliest of these laws was due to Theodore Wright, who postulated that he was in the aircraft business. He postulated that if you take, or he observed that if you take a specific kind of aircraft coming from a specific factory, and you just plot the cumulative number of planes versus the cost of making the plane, that the cost tended to drop at a rate of about 20% for every doubling in the cumulative production of the airplane. So this corresponds to a power law, and with an exponent of around 0.03. And this has now been observed for many, many different technologies, and not just at the level of individual factories, or individual airplanes, but at the level of broader classes of technologies and on a global scale. Oops, just a second. Oh dear. Okay, so now why would this be? Well, we have a paper throwing out a theory. I won't say that the theory is perfect, but it does show it and suggest some of the things that might make the exponents vary. Wright's law can work very well for many technologies. It doesn't always work, and I'll come back to that in a minute. In particular, it doesn't work for technologies that don't improve. But if you take technologies that do improve, I show some examples here, then we can see comparing Wright's law to the data. Now, the question is, how useful is Wright's law for making predictions? And so to do this, we did something that I was very familiar with from my time in the financial business. You do what's called backtesting. You pretend to be at a date in the past. You forecast each future date relative to that date, and you repeat that for all past dates, and you score the methods based on their forecasting errors. And we go beyond that by actually pooling different technologies. So we assume the basic process is the same for all technologies except for parameters. And we then showed by doing this, we can make objective forecasts with reliable error bars. And so this was the data set we first tested this method on. So we're plotting dates on one axis, cost on the other axis. You can see it's a rather motley data set, but you also see right away that different technologies like hardware, computer hardware, shows very different patterns of improvement than, say, chemical processes and other things. And so I won't go over the equations, but the point being, we can write down a time series forecasting rule, in this case with two free parameters, that then allows us to fit the data and make forecasts. And without going into any of the details, I'm flashing this slide just to say we derive a formula for how accurate those forecasts are going to be based on the parameters that we fit. We tested this by making 6,000 forecasts on roughly 50 different technologies at time horizons up to 20 years. Under our methodology, you can collapse all those forecasts onto one curve. You can predict what that curve should be if the formula is correct. And in this experiment, the data was within statistical error bars, acceptable statistical error bars of the formula that we postulated a priori. Okay, and so then you can take data like this data for solar photovoltaic modules. You take the past data, you fit the trend, you make the forecast, and the forecast is now a probabilistic forecast because you can forecast the probabilities that the costs will be at different places at different points in the future. And this is just comparing coal prices on along the bottom to solar photovoltaics and nuclear energy, and looking at the forecast we made back in 2016 and seeing that the data since then has stayed roughly on the same axis. You can also see that how favorable the costs of solar photovoltaics are beginning to look in comparison with, say, nuclear power. Now, let's apply this to climate change. How long will it take for technologies to mitigate climate change? What's the right investment strategy? Which technologies should we support? And how much will it cost? Well, to begin, let's just look at the four technologies that I mentioned and look what happens when we do these kind of tests on past climate data. And what we can see here is that if you take solar energy, for example, we see the 95% confidence bands as in these curves that are coming out. We see the trend lines from the different forecasts, and we see so we can see how good have those forecasts been. You can see that we're consistently within our 95% error bars, and the forecasts, they're not perfect, but they're not too bad. Similarly for wind on the right, and we're just taking all the data we've had, just to be clear what these plots are. We look at the experience, that is, how many cumulative solar photovoltaic modules have we made? How many cumulative wind generators have we built globally? How many cumulative batteries have we made? And how many P2X electrolyzers. So P2X is using hydrogen to make fuels like ammonia or methane, again, in a green way. And so looking at these 4 technologies as a function of the experience that we already have, had we forecasted in the past, given the experience that subsequently happened, how well would those forecasts have done? So that's what we're looking at. And so you can see for solar, wind, and batteries, it works pretty well. For P2X electrolyzers, well, the data is more volatile, which makes the forecast more volatile. We don't have as much history, which makes the forecast less accurate. The story is a bit more complicated, but it still does reasonably well. In contrast, let me just say, this isn't just cherry picking, and that back in 2010, I made a forecast that was published in Nature that by 2020, solar and wind would be cheaper than coal and nuclear for making electricity. At the time, that was viewed as crazy. This is a quote from The Economist in 2014. So 4 years after we made this forecast, they were still saying solar power is by far the most expensive way to reduce carbon emissions. And well, happily, we were right and they were wrong. Now, what about integrated assessment models and the IEA's World Energy Model? How have they done? Well, the answer is not very well. Here we see span of time from 1980 to 2030. You see the same historical curve for solar photovoltaic costs. We see the forecasts they have made at different points in time. And when I say this, people in this don't call what they do forecasting, they call it projecting. They emphasize that they aren't forecasts. So bear that caveat in mind. But nonetheless, it's interesting to ask whether their projections were corresponded to what happened subsequently. And the answer, as you can see, is that all of these projections have been way too high. They've been consistently too high in terms of cost. And that is at all the forecast dates and going forward in time. The inset shows the projected improvement rate for solar photovoltaics between 2010 and 2020. And you can see that they were all too low. And this is 3,000 different projections from all the integrated assessment models and all the models we could find. In contrast, during that same period, it dropped by 15%. In the panel on the right, you see what floor costs. And I should say that these models use Wright's law in them, but then they impose constraints, like they assume there's floor costs. For some reason, they just assume that solar photovoltaics can't go below a certain level. So here we show the historical floor costs that were assumed. And what we show is that solar photovoltaic costs have consistently broken through the floor costs that were assumed. Similarly, they also put constraints on deployment, but if you go back to these pictures here, you can see that if anything, the forecasts for Wright's law have tended to be for costs that are too high. The costs are even below what you would have had without any of the constraints. So assuming these constraints historically has always been wrong. Okay, I'll skip that. Now I'm going to just briefly present an alternative to using an integrated assessment model. The philosophy is not to find the optimal solution as they do in these models. Our philosophy is to find a likely solution. We want to demonstrate a proof of principle. So for that, we only use technologies that we can predict. For example, because we have past data. We try to make conservative assumptions. So we're not trying to make the most accurate assumption. We're just trying to show that there are, in fact, cheap and rapid solutions. We forecast the technological cost conditional on deployment. So that is, we assume scenarios for deployment, and then we forecast the cost of those scenarios, which keeps things much simpler, and it sticks to the part of the story that we have reliable empirical evidence to back up that we have, as I've already shown you, exhaustively back tested on not just energy technologies, but many technologies in different sectors. And we assume sector by sector that useful energy demand continues to grow at 2% per year. So we're not making assumptions about efficiency. We're not making assumptions about personal sacrifice. We're just assuming, in that sense, a business as usual scenario where we go on having energy growth, which you have to bear in mind if you're a developing country, may be highly desirable from an economic point of view. And then we create a solution that can supply all of our needs sector by sector, and we just add up the future technology costs, making our forecasts. The key technologies that drive our scenarios are solar photovoltaics, wind, batteries, and P2X fuels. We extrapolate existing deployment trends. We phase out fossil fuels over the next 25 years, and we use P2X for energy storage. In fact, we assume that we make so much P2X fuels that we can run the entire global energy economy for 1 month without any sun or wind. And we use P2X fuels also to do the hard to decarbonize sectors like heat, for where you need heat, like shipping, air transport, etc. So the scenarios look like this. I won't dwell on them too much, but that big orange block is solar. So you can see under the fast transition scenario, we have a big ramp up of solar energy, a big ramp up of P2X fuels, a big ramp up of wind electricity, and a phase out of just about everything else. We do let the system hang on to the nuclear power that it already has and phase out the nuclear reactors as they come online. Now, just to look at 3 of these in more detail, here we have solar, wind, batteries, and P2X electrolyzers. I show the history on the and the black dots. We fit a trend line in the red dashed line, so you can see what the trend line is for exponential increase. In every case, it's an exponential increase on the order of 30% to 40%, depending on the technology. And so I then show the 3 different scenarios. So the blue one is the fast transition. The gold one is the slow transition, which is like the fast transition, but everything happens more slowly. You let natural gas hang on for another 50 years and so on. And then the black one is a no transition, a business as usual, in which we freeze the energy production of fossil fuels, roughly speaking, and then take the growth by using renewables, but let fossil fuels stay at their current level indefinitely. So, so you can just see, I'm putting this slide up to both of all make the exponential trends clear, and secondly, to show that we're not talking about something that's crazy. We are seeing an S-curve roll off even in the fast transition. This slide shows the forecasts that we make for the different technologies using the methods that I've shown. And so we see solar, wind, batteries, P2X electrolyzers. We see, now we're plotting things versus time rather than versus experience. Things are plotted versus experience in the insets. We compare to some of the other forecasts that have been made, and we show you the 1 standard deviation and 2 standard deviation confidence intervals of our forecasts. And what you can see is that our forecasts for the future are still consistently much more optimistic than those of the IEA or of the integrated assessment models. And I should have stressed, these are the most optimistic scenarios for integrated assessment models. These are the aggressive renewable scenarios. Below, we show our forecast for oil, coal, and natural gas. And so you can, let me just move forward here, and I'm almost about to wrap up. You can see the median expenditures per year for different types of energy. So fossil fuel versus non-fossil fuel. The non-fossil fuel is white. You see this under the 3 different scenarios. So the gray one is no transition. The orange one is the slow transition. The blue one is a fast transition. And so you can see by 2050, we've phased out almost all of the fossil fuel expenditures. And you can see, using our method, which gives us probabilities, you can look at the net present cost shown on the lower left for a discount rate of 2%. So you can see the different scenarios there. You see the, in the middle panel on the bottom, the costs as a function of the discount rate. So you can see that the fast transition is the cheapest transition in expectation or under the median, regardless of the discount rate, under any sensible discount rate. And then finally, the plot on the right shows emissions as a function of time. So it shows us if agriculture is taken care of, hitting the Paris targets under the fast transition. Now, let me just end by making a couple of broad remarks. We have a paper on technology investment portfolios, and where, in technology investments, the investment strongly influences the outcome. So it's very different than a financial investment. Too much diversification is a bad strategy, because if you diversify on everything, you don't make progress on the things you want to make progress on, or you don't make progress on anything. So it's essential to make targeted investments. And what you should do is put a few eggs in the right baskets. Let me just say more broadly, one of the things my group at Oxford is doing is trying to make a comprehensive modular climate economics model. So we divide the world into 8 different modules for the different aspects of the green transition. And we're developing each of these models independently of the others. They're either agent-based models or econometric / machine learning models for each of the different sectors, which we then put together. The model I'm showing you here is our energy systems model, but we're really developing a model that allows us to look at the whole system, the whole economy, and makes it possible to think about these sensitive intervention points in a quantitative way. So what are the sensitive intervention points? Well, I think we need to make people aware that this will be cheap, or it can be cheap. We need to remove the roadblocks to grid expansion and to this scenario in general. But I'm going to single out the grid because I think it's the biggest roadblock. My oldest son works for the Federal Energy Regulation Commission in Washington. And he told me that they have enough renewable energy projects to more than double the capacity of the US electricity system. So they have project proposals for solar and wind and other renewable technologies that can get us well towards where we need to be to do this. What's the roadblock? The grid capacity and the political roadblocks to expanding the grid. The grid needs to expand by a factor of 4, which is going to cost the order of $500 billion, which sounds really expensive until you look at the fact that we're spending $4 trillion a year on energy costs already. And that if you only make a 10% improvement over global energy costs, then you're talking about the order of $400 billion per year. So while that looks expensive, relative to it lowering energy costs, it's cheap. And if we're right, we're talking about making energy costs lower than they've ever been in history. The challenges to this are really political ones. In addition, I want to say the big thing that needs the most work are storage technologies. We know a lot about P2X fuels. It's not that difficult to do, but it does take some work, and it's going to take strong government support to make sure it ramps up at the aggressive rate so that it can continue on its current improvement trajectory. And recall, we're not talking about miracles. We're just talking about continuing existing trends. So let me just end by saying that I think we need to make people aware that climate change is an opportunity. It's not something that's going to cost us money. And whether you're a government leader who wants to see your country reach the forefront and attain energy security, or whether you're a business person that wants to have a business that will be successful and will continue to be successful 20 or 30 years from now, it's an opportunity, and we need to make people realize that and push this along. And so if we just act on these sensitive intervention points, we can really tip the energy system over into a completely new regime. Thank you. Okay.
Thank you very much. Thank you very much, Doyne.
You're welcome.
Can you hear me? Yeah.
Yep.
Great. That was great. So we're now moving over to Q&A. So please, everyone, if you have remaining questions to Ilona or Doyne, feel free to post further questions to the Q&A, or also vote for questions that are already there. So there's already quite really some really interesting and diverse questions here. So I'd like to start with the question by Nana here, which is on the top of the list, which goes to, I think, to Ilona, but also to Doyne. So maybe you can both comment on this. So the question is, how can we even reach social tipping points when neither governments nor the media report sufficiently on the extent, speed, and permanence of climate and ecological breakdown? Most time ranges presented here are too long, too late, like these several decades of norms and values in the education system that Ilona showed. Why are social movements of nonviolence, civil disobedience not discussed? So Ilona, do you want to go first?
Yes. Well, first of all, yeah, I fully agree. It's all happening too slowly, and I think prioritization is needed. Yeah, that maybe climate change appears in the media, and also like decision makers are aware of the problem, but it's not on the top of the policy agenda yet. Yeah, and I think this needs to happen. And exactly like social pressure, social movements, and protests are extremely important to push decision makers. However, at the same time, I think there are some positive examples. So, for instance, I looked in my work recently at the carbonization of cities, for example, Copenhagen or Vienna, and they're actually climate change events, like in Copenhagen, the COP conference, but in Vienna also Fridays for Future demonstrations. They actually led to a change among the local politicians, and they pushed for this commitment to carbon neutrality. So there are some effects, and maybe on the kind of positive side, one more issue is that you have to remember that it's not year zero of global decarbonization. That those changes have already started to take place, probably around 30 years ago. I hope that we are actually on this kind of edge of tipping, or who knows, maybe the world has already tipped and we still kind of observe those fluctuations. But of course, we cannot say, but also those figures that Doyne showed were quite clear that maybe actually we have already tipped. Okay, maybe Doyne, you want to comment?
Well, just to add that, we have to bear in mind that in many countries, the United States, for example, the media is a commercial capitalist enterprise. And so some groups have been clever in grabbing the attention because it's about entertainment. And so, the groups that have done that have, I think, had an impact. I think we need an ecology of different approaches. And so we need to get their attention because they're just ruthless capitalists. And so we need to learn how to play that game and make things happen or bring about change. I mean, I think we do see better reporting. The BBC is a lot better than the media outlets in the US. So we need to do some mixture there.
Right, thanks both. So there's another popular question for Ilona here, which is, I think, really important point about the effects of diversity and cultural differences in different regions on that, maybe the potential for social tipping points to be triggered, but also for the roadblocks, I guess, that we just talked about.
Yes, exactly. well, there are those important differences, and maybe and exactly, I fully agree that I think like each region should have their own kind of pathway to decarbonization. Like many experts give this example that in the global south, actually, renewable energy generation could happen, or those systems could be built quicker and kind of with skipping this kind of centralized stage that we had in the global north. So definitely this is important. And maybe I should also say that most of the experts in our research were from the global north. So maybe this narrative that I presented, it's more relevant for the global north than south. But as I mentioned, yeah, maybe actually there could be some advantages that could be used in the global south. Also, maybe like on this kind of normative aspects, like many indigenous approaches, they actually are very useful into like those normative and social changes. Yes, actually, many indigenous religions, they have this kind of aspect of respecting the environment and kind of the boundaries of local environment. So I think this actually, like those kind of narratives for the global south could be kind of built up on those kind of approaches.
Yeah, Doyne, do you want to add to that point about diversity and so on related to your technological innovation?
Yeah. I mean, I think it's certainly true that the right solution really depends on the region that you're talking about, both technologically and even politically. And, you know, I think we also see the power of regional movements in what's happened. There are many cities, even in the United States, there are many cities who are really have strong programs to try and get to zero net emissions very quickly. And so these things can be very inspirational. They can also show the way in terms of business. Take, you know, the Danes who, you know, in 1990, I remember going sailing for the first time in Denmark and seeing the windmills on the horizon. There are many more now, and the Danes have become leaders in wind technology. So it benefit, not only did it get them green, it benefited their economy. So I think it also allows us to do experiments and see what works. You know, in the US, every state has a different energy policy. Every state has a different way of trying to encourage or not encourage renewables. And so you can see, for example, from there that renewable portfolio standards are much more effective than carbon taxes. They make things happen. Carbon taxes don't work. So we can do these sociological experiments and therefore find the right way forward by going down to regional levels. So I think for many reasons, it's really valuable.
Right, thank you. So over moving on, also another question to Doyne, a bit more on specifically on these rights type, Morse type laws that that you showed for technological developments in renewable energy and storage. So do you think, or do you know if these laws could also be applied, or is there evidence for them in social behavioral innovations, for example, rather than just technological ones?
Yeah, well, so the first answer would be, I don't know, but to say what I do know, you know, the closest thing I know of is software. And that is there, you know, you can look at open source software projects, you can look at metrics for software and so on and see have they improved through time. Because after software is in some sense a social activity, it's not a physical technology. And so there is some evidence for that there. Certainly the improvement is quite dramatic. The problem is that when we think about technologies, we have clear ways of saying what improvement means. We can measure things like cost, or you know, how much energy can we store per unit volume or per weight. So we have clear metrics that we can track through time. In most social things, it's harder to form those metrics. So let me just give an example. Well, this is kind of in the intermediate. You know, a lot of people, you could probably do much better than the scenarios we presented by making use of smart grids. So in other words, rather than storing, I mean, we did brute force. We said, let's just store enough hydrogen-based fuels that we can run the grid for a month, or run the whole economy for a month without any sun or wind. But you can probably do better, because of course the wind and sun don't stop blowing everywhere at the same time, by just using smart grids to move things around. We didn't include that because we don't have it's hard to measure what that really is. We don't have the historical data to make a prediction. So we fell back on something we could predict. Steven Pinker in his book has documented a lot of things that are really social. You can look at violence, for example. Violence has been going down significantly since ancient times. I remember at the Santa Fe Institute, one of my anthropology colleagues pointing out that if you open graves of Native Americans, a third of them die from a head injury from being hit with a club. So nowadays, most people don't die from violence unless you're in the Ukraine. But yeah, so so that was a long answer to basically say it's a really interesting question. I think the key is to find the right metrics and try and measure the right stuff. Steven Pinker's done some of it, but I don't know. And I think it needs to be done a lot more systematically, and it's a really interesting thing to do.
Yeah, thank you. So one question that has come up, and it's a thread that comes up in several of the questions in the Q&A, is the effects of polarized societies, where you have particularly in the US, but also in other countries, of course, high polarization around the topics of even if climate change is seen as a threat, a problem, or even a reality, how do you see this as a factor that may be a particular problem in bringing about these social tipping changes? So maybe Ilona, do you want to start with something?
Yes. Mm-hmm. Yes, so it's a very interesting question. And in a way, you think about polarization or maybe even those kind of like right-wing movements, these are minorities that are changing the majority. Yes, so of course there are negative trends, but in a way they show that small groups can change the dominant political discourse. Yeah. So no, maybe this is a powerful example. But but in general, this is a problem, and I think it's related also to the way how our communication works now. Yeah, with social media, for example. Yeah, that previously, like with kind of like more centralized, like newspapers and TV and so on, you had some sort of like some sort of filtration, yeah, or at least. Someone with probably some level of education filtering what gets to the media, and now with social media there is no filtering, and also behind like you also have some interest groups, yeah, and I think how to counteract it. I think there's even some research showing that we need more exchange across different groups, and this could be further supported by the different algorithms that social media use. Yeah, because currently, like, you get more recommendations or network connect, or kind of those friendship proposals and so on, and those algorithms follow kind of similarity, no differences. So maybe like changing algorithm that you get kind of like more random content. Maybe this could help. And this is actually doable, yeah, that you could impose like the change on the algorithms that social media operators are using.
Yeah, well, I guess, polarization is a huge problem. And, so it's quite depressing to see that it's getting, it's just keeps getting worse. My colleague, Peter Turchin in Vienna, has developed a polarization index that you can run back on the text that's circulating in different periods of history. And when you see this for the United States, it's kind of frightening because the polarization, it starts out pretty low around the time of the United States is created. It goes along at a fairly level place until about 1850 or 1840, and then it just starts shooting up. And then we have a civil war. That civil war in the United States was an event that per capita was worse than World War II, right? Then it drops back down after the war. Somehow after the war, things got quiet again. And now in the last 10 years, it's shooting up and it's back where it was just before the Civil War. I don't know what's going to happen this time. It's quite a frightening proposition. I think one of the reasons I'm enthusiastic about pushing what I'm pushing here is that even if you're a right winger, even if you don't believe in climate change, I want to say economically, this is what we should do. And why? Well, because technological progress actually plays out in this way, that you have diverse competing technologies and renewable energies, that is solar, wind, batteries and PV are really different than fossil fuels. And because of that, we can take advantage of that even economically. Now, in the numbers I was quoting, I wasn't even talking about the huge benefits of climate change mitigation. And, but so that's one reason I'm trying to do this, because, in the US ultimately, well, and really for the whole world, it's a global phenomenon. We really need to deal with this.
Maybe like a short comment is that, yes, I mean, there are those huge benefits, but I think the problem is that changing the distribution of cost and benefits. And, the winners in the current system, they probably won't be winners in the carbonized system. So I'm just thinking about, for instance, the centralized energy systems, yeah, that you have like a different stream of flows, yeah, and if you decentralize the system like with renewables, like you change the flow of benefits. And so I think this is extremely important here. So there are those wins at the global level, but still, I think maybe we need to think of kind of new business models that would allow those major players to kind of keep some level of benefits in the centralized system.
Yeah, could I just say one more thing, Jonathan? That sure. I think the incumbents are a big problem. ExxonMobil, they're fighting like hell, and they have this crazy scenario of what's going to happen. I think, in my investment, I don't just not invest in fossil fuels. I short the fuckers, and I really I want to make money off of watching them burn, and pushing them down. But so we've got these incumbents that are immorally pushing the system towards disaster just to make money, and we really have to fight against them and expose them for what they are. I think we also have to think about equity and justice. And one of the good news is that we're doing studies on labor, and from our studies, it looks like the green energy transition net creates jobs, it creates cleaner jobs, and so it's good for the world for other reasons too, also for social justice. It also levels the playing field between countries, because almost any country can produce it. It doesn't depend on whether you have fossil fuels in the ground. It gives better energy security, and so there are just many, many advantages of making this transition.
So there's a question by Fabian Daplander here, which is also going in this direction of the vested interest, the stranded assets of where for example oil majors are being seen as major players that are sticking to the business as usual energy system, and they are huge of course political influences and lobbying, etc. involved. So how is there, how problematic do you see these political factors, and how would you factor them into your forecast? Doyne, for example, when you look at these exponential trajectories, I mean, could it be that, for example, you have some kind of a rebound effect where you have exponential decrease in costs for solar, say, but there's still this baseline of fossil fuels that will still be burned because it's there and there's a huge interest to burn it, so that you will actually not really reduce your carbon budget as much as you would like to.
Yeah, so it's a big problem, but I think it's surmountable in that, first of all, it's worth remembering there's a large turnover in the energy system all the time. We're constantly replacing, petrol stations and pipelines and all that stuff and so when you look at the rates between the fact that we have, if we assume the order of 20, 25 years to get there, plus the 2% increase after that, you can actually do this without having to strand very many assets at all. Now, secondly, you can see that you reach a point where it's actually cheaper to build a new solar farm than it is to continue operating a coal-fired electricity plant, because the operating cost becomes dominant. So it's just cheaper to shut down stuff and strand the assets that you have to strand. But I think the big roadblocks are political, because the countries like Russia, they're gonna the incumbents have a huge advantage in authoritarian governments. It's already bad in democratic governments. It's much worse for authoritarian governments. And so, we do have the problem that globally, how are we going to do this with the Russians? Well, we're going to put them out of business because the only people they can sell oil to are in Russia. And it's cheaper to just buy photovoltaics and import them than it is to keep pumping their oil wells. So, but it's a big problem because one more thing I wanted to say. We've been trying to build a model for, let's suppose you're an energy company and you're making a quote, rational profit maximization decision. As renewables get cheaper, when do you start investing in renewables versus fossil fuels? And how does that depend on things like whether there's a carbon tax or some other carbon penalty? And of course, as the majority of the economy starts to tip towards green, the green become more powerful lobbyists, and you get a big feedback effect that kicks in on top of Wright's Law, which is already a big positive feedback effect. So you have a double tipping point. And so I think that will also kick in, but we've got to get the system up to that point.
Interesting. Ilona, you raised your hand. You want to add to that? And
yes.
maybe also could I ask you to bring in this, before we wrap up, this aspect of the role of social movements, which has been raised in the chat and in the Q&A as well, where there's, of course, and strong, there's some efforts going on in Fridays for Future, etc. And what could be the role of them to break these roadblocks?
Yeah, well, maybe only shortly about fossil fuel companies. So there are some changes also happening. So I'm just looking at that right now, and it seems, for instance, like BP is changing. Yeah, so they changed their extraction projections, and they started to invest more in renewables. So I don't know yet. Maybe it's only greenwashing, but it might be that. But maybe there's an increasing awareness of those companies, like what is happening, and some are really. Truly starting to change. But the tragedy is that the biggest fossil gas and oil companies are actually owned by national states. Yeah, and this is what also Doyne mentioned, that many of them are owned by those kind of authoritarian regimes. Exactly, and then we get to social movements and civil disobedience. I think this is extremely important because, probably like more kind of aggressive type of movements are needed to push those companies, and this is also happening. Like for instance, like many pipelines are blocked by native communities, or also like in Germany, even like those sites where like for lignite coal extraction are also blocked by activists. So I think this is extremely important, but this also has to be done strategically, like what kind of civil disobedience and where and what and whom to block, because maybe just kind of like, I don't know, stopping people on the highway, it has this kind of counter effect that kind of average citizens get against all those movements. Yeah. So yeah, so I would say maybe we need exactly more research, like what kind of civil disobedience makes the most of sense, and how should it happen, and what kind of rebellion type of protests are needed, and where.
Thank you very much. So this is a very, very important issue, of course, and there's suggestions for further discussions on that in the chat, further events. So, but I would like to wrap up today's event. I would like to give another round of applause and thank to our speakers, Ilona and Doyne. That was great. Excellent presentations and excellent discussion in response to the Q&A questions. And many thanks to all of you. Over 130 people I saw at some point here that were online watching this, and thank you for your attention and participation. Again, be reminded that the Miro board will remain active till the end of the week, so you can continue to contribute there, discuss there, and also get in touch with the organizers and the speakers for further questions, etc. Again, I would like to now draw attention to the next seminar of the series, which will focus on paleoclimate or longer term, deeper past insights on societal collapse as kind of the flip side, the dark flip side of positive social tipping, which is of course very interesting to understand the underlying mechanisms. And this will happen on the 3rd of June. It will include as speakers Joseph Tainter from the Utah State University and Ann Kinzig from Arizona State University. And the link to register will be posted in the chat box. And you can also find it on the website, of course. And after the seminar, we will take a summer break, but there are already plans for further events, for example, on coral reefs and cloud feedbacks and atmospheric interactions in fall. So this series will continue after the summer. And particularly, we would like to also take this opportunity once more to announce the upcoming tipping conference at Exeter University in September 12 to 14. So there's a screen share on now. You can also check the website for further information to get updates. This should be in the chat at some point, but also linked from the website of this seminar series. And yes, please, again, also if you would like to get involved in the TipMIP, the tipping point intercomparison project, please fill out the expression of interest form. The link can also be found on the website of the seminar series. And with that, yes, I thank everyone and goodbye.